I'm Carl Anthony, and welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information to connect engineers, scientists, and many other automotive industry experts across the globe. We're joined today by Chad Kobylanski. He is the automotive segment manager for ShinEtsu Silicones. He joins us again, returning to AutoSens. Chad, good to see you again.
Yeah, good to see you too, Carl. Yeah, last time we were virtual, but yeah, we're excited to be in Detroit this year for the on-site conference.
Absolutely. Chad, and I, thinking back to our first conversation back in 2020, I thought it was really neat, all of the things that ShinEtsu was doing, to have a silicone company involved in this space. We don't see that every day here over at AutoSens. So for our viewers who may need a refresher, or for somebody who's just meeting you for the first time, can you give us an overview of ShinEtsu Silicones and kind of give us a high-level overview of the company?
Yeah, absolutely. Thanks. Yeah, many people might not be aware, but ShinEtsu is one of the largest chemical companies. We were founded in 1926, so we're approaching 100 years in business. We have over 20,000 employees globally and have many market-leading product divisions, which many customers might be aware of us from. We're the worldwide leader in manufacturing of PVC, semiconductor silicon, rare earth magnets, synthetic quartz for photomasks, synthetic pheromones. We're number 2 worldwide in methylcellulose and number 4 worldwide in silicones, which is my divisions and those products that I'll be introducing.
Of course. So now, Chad, the $1 million question: how did or why did ShinEtsu decide to get into the ADAS market, the LiDAR market? What prompted that move?
Yeah, so around the autonomous vehicle, there's hundreds of applications, components that require silicone support, from lighting and power electronics and just the countless amount of sensors. But they're really going to require a tremendous amount of material support from the silicone to really improve the safety and reliability of the current sensor and LiDAR markets as the levels of autonomy increase. So silicone's inorganic material, and which is known for having outstanding temperature resistance and oxidative stability. So this is really the reason that we're being so closely looked at for future and current LiDAR and automotive sensor designs.
So, Chad, why is it important then to have that, as you said, temperature resistance and durability? Why is it important to have that level of protection when it comes to these automotive sensing systems?
Yeah, thanks. Good question. So LiDAR devices, automotive sensors, and pulse sensors, they're high power lasers that send out countless pulses of light, which are pushing substrates, components, and materials to the limit in thermal stability. So we're seeing like cracking occurring in older organic type materials like epoxies or urethanes, acrylics that can't handle these real high power designs that you would see in the automotive that are required for the automotive market and thermal shock testing. But we have silicone encapsulants that can withstand up to 270 Celsius long term for over 2,000 hours. And we've also developed new encapsulants. One is a black encapsulant that blocks visible light and only allows infrared radiation to pass through. It's one of the first silicone products on the market and superior to these standard epoxies and films and laminates due to its higher elongation for resistance against cracking and overall higher thermal stability. And yeah, we've also developed other, potting materials, optically clear materials to allow all this high power light to pass through.
Right. Chad, Let's talk about your customers now. And, and we've probably covered this in so many words, but let's dive just a little bit deeper. Your customers, when they come to you, what kind of challenges, what kind of problems, what kind of pain points, what kind of solutions are you helping them achieve in the automotive market?
Yeah, a lot of customers now are looking for ways of improving their current processes and saving costs as always. So
Yes.
one thing that we've been doing just recently actually is making our silicone more environmentally friendly. We've been developing low temperature curing adhesives. So these are actually UV activated adhesives. So they're initiated by UV activation, UV light, and this offers a dual cure. So it's going to be UV plus low heat. That's going to help improve and lower the overhead costs and the of heating of some of these advanced silicone materials. They have really high temperature cure schedules, but this allows you to cure the material with room temperature to lower the overhead costs on heat. And a lot of these new products too, they don't require, if they're a one-part material, they don't require any dry ice for shipping. So global costs and freight costs across the globe have just skyrocketed. So being able to ship some of these materials at just room temperature is really lowering the cost on transportation and everything.
You have that really colorful, really cool banner behind you. Chad, let's talk about some of the silicone products that you're promoting right now in the automotive sensor market.
Yeah, so again, we've got a number of advanced encapsulant materials that we've developed, including that black encapsulant, allowing IR to pass through. And then the adhesives are UV and UV curable adhesives, and our LOCA materials, liquid optically clear adhesives. So these are a great way to fixate, non-transparent components or cameras onto modules or devices, and also they offer maintain a stable modulus over a wide range of temperatures, and as well as providing excellent chemical resistance. But another way, and some of our new silicones that we're developing, another way these are helping the overall long-term reliability of these automotive sensors, we have thermal interface materials. So after doing some research, we've learned that many old generation LiDAR devices and sensors, they don't use many TIMs, thermal interface materials, around the boards or the heat sinks. So the next gen versions and these chips that are just becoming higher power and higher upload speeds and data consumption, the chips and circuitry boards are generating a ton of heat, and without the proper way of dissipating that heat, we're seeing failures and lifetime issues. There's still air pockets and voids between the circuit board and heat sinks, which is causing that thermal insulation. So we've developed a whole product line of liquid dispensable thermally conductive gap fillers, which is our SDP series. Those are available in a wide range of thermal conductivities from 1 to 12 watt per meter Kelvin. And they can be applied in the liquid state and then cured at room temperature. So they don't require any type of aggressive thermal cure or high temperature cure. And then we also have a full product line of TIM rubber materials as well, like soft and hard silicone pads, which can be die cut and placed onto a part or a heat sink, instead of investing in any sort of dispense equipment for the dispensable type of TIM products. And yeah, we also have phase change materials as well. And, a way of testing these on new designs, you can cut out, use a die cut thermal pad or, silicone pad on some of these new SDP materials. You can dispense them in between uneven substrates or circuit boards, and then cure the material at room temperature, and you'll just see how quickly the heat escapes the entire package.
Chad, back when I started my automotive career, I was a salesman. I used to sell trucks, a lot of Ford trucks, lot of Chevy trucks. And when you're talking towing and payload, instinctually, yes, you think about the engine, right? You think about that big V8 engine under the hood. But one of the things I learned early on in my career, that it was the high strength steel architecture of the truck that actually helped with the towing and the payload capacity. And what you're talking about, to me, is very, very similar, where you can have an awesome lidar engine, you can have an awesome automotive sensing engine, right? But it's that high strength steel architecture, or in this case that silicone architecture, that really allows it to do its job.
Mhm. Yeah, yeah, exactly. I mean, especially for like I mentioned earlier, as the self-driving cars and the levels of autonomy as they continue to increase, the chips inside, they're just putting out so much more output, and it's really pushing all the materials to the limit. And yeah, you just need a material like silicone that can really hold up and continue to take on these generations of new designs and chips.
Right. Chad, before we wrap up here, one last question I want to pick your brain on. We're talking about ADAS and autonomy, which usually leads into a conversation about software defined vehicles and electrification. Are there applications there for ShinEtsu silicones in terms of a software defined car or an electrified vehicle? What are your thoughts on that?
Yeah, so I just think, yeah, the number of applications and needs for silicone material and in general is just going to keep increasing with electric vehicles. I mean, even outside of the vehicle, in these in the charging stations that are needed to power the vehicle to get from one place to another, or increase the miles that are driven. Yeah, it's just, there's applications even in the charging station, power electronics, potting, and all these different ways of utilizing silicone.
Chad, we're so happy to have you and ShinEtsu as part of the AutoSens community. You bring such a unique and just different approach that we don't see every day. For our viewers and our attendees who are interested in learning more, what is the best way that they can reach out to ShinEtsu? Is there a website or a LinkedIn page? What's the best way to get in contact with you?
Yeah, so we're at shinetsusilicones.com, and yeah, we're excited. This will be our first year in person at the AutoSens show, so we'll have a booth, and we welcome everyone to stop by and learn more about our silicone, and reach out and see how we can help support you.
Chad, let's get caught up in Detroit when you are here. Thank you for being with us today, sharing your expertise and your thought leadership. From all of us here at AutoSens, we want to wish you the best of luck going forward, and thank you for your time today.
Absolutely. Thanks, Carl.
For more interviews like this, subscribe to the AutoSens YouTube channel and follow us on LinkedIn and Twitter. For more information on our world-class events and technical training, visit auto-sense.com. That's auto-sense.com. In Detroit, on behalf of AutoSens, I'm Carl Anthony.